So hey everyone, in this video we are going to understand how can we traverse a given graph. So what do I mean by traversal? Let's say we have this graph. How do I grab in values? Let's say I want to store all of these values in the form of an array. So how do I store it? There are two ways of traversing a graph. Okay, so I can just traverse from A, B, C, D, E, F in a horizontal fashion. So that is called as breadth first traversal, where I go across the breadth first, and then there is another traversal technique called as depth first, where I go as deep as I can within the tree and then go to the next element and go deep as possible. Okay, so if I show you the depth first traversal, it would be A, B, D, C, E and F. Okay, so we are going as deep as possible and then moving on to C, okay, and then go deep from there and then go to F. Okay, so this is how we traverse a given graph. Okay, so this is just a simple graph where this is not even a binary search tree or anything, that simple binary tree. How can we traverse this? So we want to implement methods, or like whether we want to breadth first traverse or depth first. Okay, so by using the same example that we used while constructing a simple tree like this, we are just going to apply the traversal technique. So let us start by creating a function that will implement the depth first traversal and then store all of these values in the form of an array. Okay, so the result should be A, B, D, E, C and F. Okay, where we are doing the depth first. So let's go ahead and create that function over here, where I'm going to call that depth first traversal. So okay, so this is going to take in the root of the tree, so we can just pass in the root over here. So any tree that we want to traverse, we always start from the root, right? Either breadth first traversal or depth first. So we just first want to check if the root even exists. So if no root, then we just want to return an empty array. Okay, so the array is a type, right, which we are going to return at the end of this function. So we just return an empty array. So if there is a root, we just create a results array. So result, and this is going to be an empty array where we store all of the traversal nodes values inside this. And here for the depth first traversal, so in the depth first traversal we are going to use a stack data structure. Okay, so in the breadth first we are going to use queue, which I'll come back to that. So the reason why we are using stack is we are going as deep as possible and put all of those values inside the stack, and once we find a leaf node, and then we just start popping off elements from the stack and adding them to this result array. Okay, and then go to the next value, that is C. Okay, so that is right side of the root, and then do the same again. Okay, so that's why we are going to use a stack over here. So let me also initialize that, and here after this we just want to push the root element to the stack. Okay, so we are going to get started from the stack. So stack dot push root, and now we just want to run a while loop. Okay, so this loop will keep on running as long as there are elements within the left and the right. Okay, so basically it's a binary search tree, right? We have two values, one is the left and one is the right. Okay, so we want to run this while loop as long as there are elements within this stack. Okay, so we can put a while and say stack dot length is greater than 0. So basically as long as we have elements within our stack, so we just want to keep on pushing them to the results array as I told. So we say result dot push and then pass in the particular element. Okay, so basically we have the data, right? So this particular root has a data or a value, right? So we just need to grab that value. So we can just store that within a variable called, let's say, current, and set that to root dot value. Alright, and then we just want to push the current like this. Okay, so now we just want to check for the left and the right values of this root. Okay, so this A is the root, right? So it has left as B and right as C. Okay, and indeed they are also nodes as well, so even they also have left and right properties. So we just keep running this loop, okay, as long as we do not have elements within our stack. So we just check if current dot right exists, then we just want to push that to the stack as well. Okay, so that is current dot right, and let's do the same for the left as well. Okay, so we can just duplicate this and set this to left and push current dot left. Okay, so the reason why we are doing this, sometimes we do not have a left element. You see that C doesn't have a left. Okay, so we are putting that check over here and we only push those elements that exist. Okay, sorry, this current value should be the value that we are popping off the stack. Okay, so we pop an element from the stack and then we check the left and the right values and then add them to the stack. Okay, so we keep on pushing them simultaneously along with checking the right and the left values. Okay, so I hope this makes sense. So sorry for this mistake, I just got confused there. So stack.pop is a method that removes an element and returns it. Okay, so we are storing in that current, and then we push that to the results array, and we check for this current one either we have left or right. Okay, so and then we add them to the stack and then keep doing this again and again. Okay, so we just keep on pushing that and check for the right and the left. Okay, so I hope that makes sense. So now finally we just return the result after this while loop. So return result like this, and finally we can just call this particular method over here and by passing in the root. Okay, so the root we just created in the one of those videos by this tree node, and then a is a root, right? Since we are starting from a, so we can pass in a over here. So now if I save this and run this particular file, so basically I need to console log this, which I every time keep forgetting, and yeah, this will return the result. So let's run this file. So here we are getting an array of tree nodes. Okay, so with the left and the right property, which we do not want, so we just want just the value, right? So I forgot to pass in value over here. So once I save this, you see that we are getting an array of all the values. So we go from a, b, d, e, c and f. Okay, so if we verify that a, b, d, c, e and f, okay, so that is the traversing which is happening. Okay, so first it traverses on the left and then goes to the right and then again left from there and then goes to the keeps on going like that. Okay, so this is how we can implement a depth first traversal within a given binary tree. Okay, so this doesn't necessarily have to be a search tree. So this can be any tree and of any value that a node can hold. Okay, so let's also implement a method to traverse a given tree in a horizontal fashion, basically the breadth first traversal. Okay, so let's construct a function called breadth first traversal. Okay, again this is going to take in the root of the tree, and inside this function we just want to get started the same way as we did for the depth first traversal. Okay, so the only thing that is different from the depth first traversal is that we are going to use a queue instead of a stack. Okay, so for depth first we use a stack, and for breadth first we use a queue. So what is the main difference between them? Stack is whichever element goes inside the stack will be the first one to be popped off, right? So the queue is opposite, so which one the first element to go inside the stack will be the last one to get out. Okay, so that's the only difference. So we are just going to again use the array itself, but we are just going to use the shift method on arrays. Okay, so shift is a method which you can use on arrays to pop off the first element instead of the last element. Okay, so the pops the last element, but the shift method pops in the first element. Okay, and then again it returns that. So let's do the same over here. We can just copy this and then we can just change the values over here. So it is almost the same, and we can just replace stack with queue. Okay, and instead of using the pop method we can use the shift method on arrays. Okay, so this will pop the first element and return that, and yeah, so it is still the same. If I now run this particular file over here, so let's say I cut this and put this over here and rename this to breadth first traversal. Okay, so now I go here, you see that we are going from A, C, B, so we are going the reverse order. So we need to push the left element first and then right. Okay, so that's why we are getting reverse order. So I'm also showing you all the possible mistakes or the errors that we can make. Okay, so this is the mistake that I made, like by setting right first and then left. So we got this result which we are not satisfied with that, so we just modify this and then we get the expected results. Okay, so we just this is a development process, we just keep on iterating and then get to the final result, right, that we expect. So now you see that we are getting an array of A, B, C, D, E, F. Okay, so that is horizontally traversing by breadth. Okay, so A, B, C, D, E, F. So this is the method. The only difference is for breadth first we are using queue, and for depth first we are using a stack. Okay, so this is the traversal techniques that we have within a tree. So I hope you like this video. If you have any questions, please let me know in the comments. So thank you so much for watching. Make sure you subscribe. I'll see you guys in the next video.